In my real-life example, I want to create a quadratic function to model the arc of a projectile shot at an angle of 30 degrees. I will also have a simulation that I created in Unreal Engine to help show the projectile motion. After a bit of research, I found that a 155mm artillery shell has a velocity of 563 meters per second, which will help me calculate the distance and the time that the projectile traveled. First, let's find the time it took from when it was launched to when it hit the ground. We are going to disregard air resistance, and to make the problem a little easier, the howitzer will be in a hole, where the muzzle or firing point will be equal to 0, 0 on a coordinate plane. We need to first do some trig to find the magnitude of the vertical component. Knowing that 563 meters per second is the hypotenuse, and the vertical component is the opposite of the 30 degrees angle, then we can use sine. You will need to multiply the hypotenuse with sine of 30 to get 281.5 meters per second for the magnitude of the vertical component. Now, to use this to find time. Disregarding air resistance, we can assume that the magnitude will stay the same in the opposite direction. Up is positive, down is negative. Using the formula final velocity minus initial velocity to find the change in velocity, we can plug the values 281.5 meters per second for the initial and negative 281.5 meters per second for the final velocity. The change in velocity will equal negative 563 meters per second. The change in velocity is also equal to the vertical acceleration multiplied by the change in time. We know that the vertical acceleration will be negative 9.8 meters per second, as the projectile will be in freefall. We then solve by dividing the change in velocity by the vertical acceleration to get about 57.45 meters per second for the total time it took. To find the distance, we can use this formula, where I can just plug the values in to get this as the answer to our distance. Now we can use what we have to find the vertex of the arc. We know how far it traveled and the time it took to travel that far. Again, disregarding air resistance, the parabola will be symmetric along with the fact that there is no elevation. This means that half of the total distance will be the x-coordinate of the vertex. To find the y max, we can use this equation. Before plugging everything in, we need to find the time that the projectile was at its maximum height. We can do this a couple of ways, dividing the total time by 2 just like the x-coordinate, or use this equation. After solving, the time will be 28.72 meters per second. And now we can plug the rest of the values into the equation to get the answer 4042.97 meters as our total vertical displacement. Now we can plug the vertex into vertex form. All we need to do now is to find a. We can sub the values 0, 0 in for the y and x, and once it is solved, we get this as our a value. The final quadratic function will be this. Plug that into Desmos, and wow, it's an arc. Why not go a step further to check if the arc is correct? After a little coding and converting meters to centimeters to incorporate them into Unreal Engine, we get this as the final result.